Hello guys, this is Krish here, and today I'm actually trying to show you how to use Python in calculating the overall supply chain performance. So the overall supply chain performance can be measured just like overall equipment efficiency. So if you know overall what is overall equipment efficiency, let me show you what is overall equipment efficiency, which is used mostly in lean manufacturing or total productivity management (TPM). Overall equipment efficiency. Similarly, before I show what is I'm trying to do on the supply chain overall performance calculation, I'd like to show what is overall equipment efficiency. I hope you're able to see my screen and able to hear my voice as well. I hope. So let's see what is overall equipment efficiency. Suppose you want to understand whether your machine is working well and your machine is giving you good results, right? So what you want to know is that your machine is giving good results to you. So you want to see that your machine is performing at a rate what it is designed for. The gap between design rate and the actual rate is almost less. Right? This is what you want to see. First thing you want to see is this. Second thing you want to see is your the quality, right? So the design for the quality. Suppose if you have the machine has been designed to generate a 99% quality rate. So what is the actual quality you're getting? So the design quality rate versus the actual quality rate. Second thing, what you want to see in a machine is this. The third thing you want to see in a machine is how much time it is under shutdown and how much time it is working well. So suppose if you are the machine is designed to operate for 16 hours a day. Out of 16 hours, how much is a breakdown hours? Let's say 2 hours. So the 14 hours is the actual operating time. So the design or planned sorry planned operating time versus the actual operating time, right? So this is what you if you so you want to see your machine is working as per the design rate, or means that gap between design rate and the actual rate is very less. You also want to ensure that the product which are coming out of the machine are actually as per the planned quality, as per the planned uh, uh, rate. Means if you're planning, if you thought that your machine is going to generate 99.9% or 100% quality, means suppose we are generating 1000 units out of the machine, or 1000 out of machine. So how many products are actually quality approved? So if you want to see all of your units of products are quality approved, then that is 1000 out of 1000, means 100% is the quality approval rate. So how much is your quality, how much is your approval rate, is something is also one what you want to see from the machine. If your machine is giving you more defects, then I think you're not achieving your actual planned or actual plan go or the actual goals which you have thought about. So what you want is that your machine has to perform, generate a good quality. Your machine has to produce high volume. So suppose if you are thought that every hour your machine is designed to generate 100 units per hour. That is a machine design capacity. But if you see that the machine is producing 50 units per hour, so that is a gap between the actual design capacity and the actual capacity. So that's what you want is that your machine is generating high volume, means that it is generating as per the designed volume, design capacity, right? So what you want is the machine is producing a high volume, and whatever high volume it is producing, it is also generating a high quality from that high volume, right? And also you want to ensure that the machine is operating, you know, the the planned the planned operating as per the planned your operating hours. That means there's minimal shutdown, right? So if you want to sell your product to the customer, you want to sell to the customer, very high volume, and whatever you're selling to the customer, that should not be rejected, right? So that's if your products which are coming out of the machine are being sold in high volume, and none of them are rejected, or if you have designs and one if you have designed for 1% rejection or less than 1% rejection, so whatever percentage you have designed for the rejection, if it is below that, then I think your machine is working very well. So that is what we say overall equipment efficiency means. Your machine is having very high efficiency because it is able to generate high volume. It is able to generate whatever high volume. It is able to generate high quality out of the high volume, and your machine is working a high operating hours with minimal shutdown, right? That is what we want to see overall equipment efficiency. So I will define this function in Python, right? I'm working on right now a tool called Python, which is a data analysis or data analytics tool. So on this, I'm going to define this particular function, and then we'll move to a supply chain function, supply chain, metric function, and we'll apply the same concept there also. So let me design what is this, how to work on this by using a Python and generate this particular function in the Python. Then we'll move to second phase. So be with me, guys. And so here is I'm going to define a function. So this is a code like def, a very simple code. Define. I'll say define overall equipment efficiency. So OEE, I'm going to define overall equipment efficiency. So in this case, I have three variables here. The three variables, then the three variables here is the first is the capacity. So I'll write CAP. I'll just give a name called CAP, capacity. And second is quality, CQAL, quality. And the last one is the operating hours, OPH, right? So this overall equipment efficiency is being derived from three variables. So capacity, quality rate, and the operating hours. So I'm going to define this. I'm going to define a metric, and that is called, let's say this is a metric underscore one is equal to, I'll say capacity into quality into OPH, operating hours, right? This is my metric. So I'm going to publish this metric this is a formula, metric one, and we know what is metric underscore, that is capacity into quality into operating hours. So now I'm going to define the function, and this is a function is O operating hours, OEE, right? And here I'm going to define, let's say my capacity means the gap the gap between the design capacity and the actual capacity, right? The design capacity and actual capacity. Let's say this is the effectiveness is at 88%. Means let's say if the design capacity is 100 units per hour and the actual capacity is 88 units per hour, and we say 88 divided by 100, that's called 0.88, right? 88. Now, what is the quality? Quality rate is, let's say, 95%. So 0.95 means we are generating 88 units per hour. Out of 88 units, 95% is 88%. Out of 88%, 95% is high quality, right? So that is 0.88 into 0.95. And then our machine is able to operate, suppose we have the machine, we are the shift per day is 16 hours, and out of six per shift per day 16 hours, 2 hours is the average shutdown time. So 14 hours is the actual operating time. So 14 by 16, whatever is 40 minutes, let's say this is 0.90. So this is a function which I have designed in Python. I'm going to run this code now. Let's see what is the output we get here. We're getting some error here. So let's see what is the error. Cap, call, and OPH. So cap, call CQAL quality OPH, and there is a syntax error is it's mentioning. Yeah, the syntax error is I have to put some semicolon here, colon here. So let's rerun the code now. So guys, this is the code which we have mentioned the operating in the Python, and this code is going to be this is a constant code, and if in any time I have to calculate the overall equipment efficiency, I don't need to. So I think this is one more mistake I did. I have put here the multiplication sign, so I have to remove that also. There is some bugs which came into the code, so I'm removing those bugs, and I'm finalizing my. And so let me see. I think there is one more error somewhere. So let me put here the comma, and after putting comma, I'll put 0.90 and then close the bracket. So I have defined my three variables, and I defined a formula also, and then after that I gave a values to my those three variables, and let's see whether we are getting the. Again, there is some kind of issue here. So the formula of the spelling of print is not right. So I'm going to remove this e here. So let me run the code again. So we are able to understand where we are making our small errors. So we are rectifying those small errors and running the code. So now we see, let's see whether we get the output. Yes, now we got the output here, and this is 0.7524, means 75%. So the overall equipment efficiency by, if our uh, capacity efficiency is 88%, quality efficiency is 95%, and operating hours efficiency is 90%. If this is what our efficiency of these three variables, the overall efficiency when we combine all of them together, then we get 75%. That is 0.7524, right? So this code which I'm having right now, I'm going to use this code. I'm going to save this code and apply this code every time I have to run. Every time I have to calculate the overall equipment efficiency, right? So this is the code which I'm going to run. Now I'm going to apply the same thing on our another metric calculation, and that is called the supply chain metric calculation, right? In supply chain, let's say I'm going to come. I want to understand what is my return rate, and I want to combine the return rate and the on-time delivery. I want to combine the returns, means I'll say quality or return rate, or say quality and the on-time delivery. Right? This is what I want to combine. I want to combine the quality and on-time delivery, and based upon this, I want to generate the overall performance of supply chain. Right. So if you want to understand the supply chain performance from the on-time delivery point of view, you can take it separately. If you want to understand the performance by the quality rate, you can just calculate from the quality point of view. But if you want to understand the overall supply chain efficiency by combining the quality and on-time delivery, this is the metric I'm going to use. So here again, I'm going to define the metric and say define, and I'll say overall supply chain metric, OSCM, and I say here this is my OTD, comma, and quality rate, QR. I'm going to put colon here, right? And I will say my metric underscore 2, because we have already given metric underscore 1 in the previous case. So this will be OTD into QR, right? And I'm going to print this code metric underscore 2, and then finally I'll define my function based upon this. So OSCM, if my on-time delivery is 75% and my quality rate is 85%, what is my current supply chain performance? Let's run this code. Yes, I'm running this entire code in Python environment, right? If you look at here, this is coming around 63.75. So the overall performance, supply chain performance is 63.75. You can see, can read over here, right? The 63. Let me again put point here. I think I did missed point. Let me run this code again. So it will be 0.67.675. Something will get. Let's see how much we get. Yeah, 0.6375. This means 63.75%. If your on-time delivery is 75% and if your quality rate is 85. Let me change these numbers now. Let me say my on-time delivery is increasing. It's 0.95 and my quality rate is still is 0.85. In that case, what is my overall supply chain performance? So I'm multiplying supply chain, I'm multiplying the on-time delivery and the quality rate to generate the overall supply chain performance, right? So if see the as we have increased, the moment we increased our on-time delivery performance from 75% to 95%, our overall supply chain performance has increased to 80.75%, right? Now, if I suppose increase my quality rate from 85% to 90%, what happens now? So I'm increasing my quality rate from 85% to 90%. And in this case, what will happen now? Right now, if you see, this is 80.75% when we have our on-time delivery 95% and quality rate equal to 85%. Right now, what I did is I increased my quality rate from 80% to 90%. So in this case, now let's see what will happen to our overall supply chain performance. Now, if you look at the previous, when previously when our quality rate was 80%, 85%, right? And so we had our overall supply chain performance equal to 80%. A moment we have increased from the quality rate from 85% to 90%, our overall supply chain performance also has increased, right? Similarly, if I make it 95%, the quality rate becomes 95%. Now we have 85% when the quality rate is 90%. Now, if I make the quality rate to 95% for 90%, what is the improvement we're going to notice here while running the code? So let's see. So it is computing now. See, it is 90.25%, right? So as we are increasing our quality rate, our overall supply chain performance is increasing, right? Now, if I improve my on-time delivery percent from 95% to 98%, what will happen now? Right now, we have 90.2% as our overall supply chain performance. Now, what I'm doing is I'm increasing my on-time delivery percent. So, what is going to happen now? Now, see, it was 90% earlier. Now, it is 93% now. A 3% improvement we are noticing here. So, this is a code, guys. So, we are defining a code in Python environment. So in Python environment, we defined a function that's called overall OSCM, the overall supply chain metric, and we are using two functions, two variables there. One is OTD, that's on-time delivery. Second is QR, that's quality rate, and then we are defining our metric. That metric is the product of on-time delivery and quality rate. And then we are actually trying to tell the Python that we have to publish this. So we are trying to publish this formula or to using a code called print metric 2. Then finally we are actually defining our values, what kind of values we will be able to insert into the function which will generate the output out of this, right guys? This is how we are using the Python environment to compute a function, and this is a function which we can use in doing a lot of computations when we write the full code. So guys, if you want to learn Python based supply chain analytics, you can connect with me on the given details, which is already being running on the screen at the bottom. There's my email ID is krishnaidu@mathal.com and the WhatsApp ID is +918977924637. And if you want to connect us to a social media page wherever you're watching this particular video, you can also connect from there. Also, we'll be replying you back. And we are also launching a demand forecasting course, online course, from 14th of January. If you're interested, you can connect with me on the same. Thank you very much, guys. We look forward to you for another video and some other time. Thank you very much.